Okay, one more example transforming our basic reciprocal function where we kind of put it all together. Where we have a translation, two translations. We're going to have to move our basic reciprocal function 1 unit to the left and 2 units down after, of course, we stretch it vertically by a factor of 1/2. So let's go ahead and look at our 6 points. That hopefully you're becoming more and more familiar with in the past couple of examples, and we're going to stretch those vertically by a factor of 1/2. So 2 comes down to 1, the stretch, 1 goes to 1/2, and 1/2 goes to 1/4 on that side. Same thing over here, except these are all negative values. -1 as a y value goes to -1/2, -2 to -1, and -1/2, halfway in between there at -1/4. So we're going to try to reproduce those 6 stretched order pairs over here, but of course we need to relocate them to their new location, which is going to be moved, all those points are going to be moved 1 unit to the left because of the plus x plus 1, and they're also going to be moved 2 units down. So what's probably a better plan is just to sketch our new asymptotes. So our new horizontal asymptote is going to be at -2. And our new vertical asymptote, because of course remember we're just translating our x and our y axes, our y axis is now going to go 1 unit to the left. So of course that's our new vertical asymptote. Let's take a second and notch this out. Getting a little bit faster here with this. Maybe not fast enough yet, but you can always fast forward, which is the beauty of this. Okay, so those are our asymptotes, and now we'll just try to plot the same configuration of points. So, and what is that configuration of points? So when I go half of a box over, I'm up 1. I'll try to exaggerate that. And when I went over 1 box from my vertical asymptote, I go up 1/2. And then the next one is 1/4. And things are getting pretty tight there, but as long as we can connect those. And don't stray too far from your points, and still try to space yourself from your asymptotes there a little bit. And now for these the negative branch. So again, when I come over 1 box, I'm down 1/2. Half of a box down 1, and 2 boxes over 1/4. And that one is not even close. Let's try that again. No. There. I'll quit while I'm ahead. There's our negative branch. I think it resembles the same shape that's over there. So of course it's, I should be referring to the orange dots, of course. So there's a vertically stretched basic reciprocal, and it's also been relocated 1 unit left and 2 units down. Lastly, let's write our explicit equation for this thing. So that's good practice as well. That y is going to be 1/2 in front of our our original basic reciprocal, which is 1 over something, and I'm going to put my other y transformation at the end. So the y transformations stay outside, 1/2 in front via multiplication, subtract 2 at the end, and watch this input change. X changes now to x plus 1. And let's just tidy that up a little bit. And there's not much to do here other than just multiply the top and the bottom. So we have a 1 on the top, and we have 2 times x plus 1 on the bottom, and then separate from that we have a subtract 2. And of course if you want to multiply this 2 out and write 2x plus 2 on the bottom, that is great and correct as well. This is a little bit more typical because we make it really crystal clear where our asymptotes are located. And of course our vertical asymptote is located at x equals -1 because that creates division by 0. And our our horizontal asymptote is of course located at -2. It's always that constant that's at the end. And of course our vertical asymptote, the hint towards their location, or to the location of your vertical asymptote, of course, is what makes that 0 on the bottom, which is -1. So everything checks out, and we are finished.